Okay, so up until this point, we have only been talking about solving equations. Okay, but if we look at our picture down here below, we have Mr. Trosper and we have Mr. Potts. And I think you guys would agree that these two do not equal each other. Mr. Trosper here is much larger than Mr. Potts. And that's what we got Mr. Kavanaugh down here saying, that those two don't look the same. So if we have two problems that are not equal to each other, two expressions that are not equal, you guys are going to be dealing with an inequality sign. Okay, we've got greater than signs, we've got less than signs, we've got greater than or equal to signs and less than or equal to signs. And when we solve inequalities, you guys remember you're going to solve an inequality just like normal. But there is one special rule, and that special rule is when you multiply or divide by a negative, you must switch or flip your inequality sign. So flip to the back real quick, and we're going to work out one quick example. Okay, that one quick example is going to be 1 minus 3x less than 7. Okay, so I'm going to pretend like this is just an equation, and I'm going to solve this. Okay. That is a positive 1 right there. So to get rid of that positive 1, I'm going to have to subtract 1. And I have to do that to both sides. Now I end up with a negative 3x less than 6. Okay? I've got a negative 3 out in front of the x, so I'm going to divide by negative 3 on both sides. And when I do that, I end up with an x, and I end up with a negative 2. But, red alert, red alert. We are dividing by a negative, so since I divided by a negative, I have to flip my inequality sign. So it was a less than sign, I have to flip it to a greater than sign. And I end up with x greater than negative 2. Okay, so just a quick example there. I want to show you guys where we would use that one special rule. Okay, the last thing I want to talk to you guys about, and we've talked about these before, you have bounded and you have unbounded intervals. Okay. When you are dealing with a bounded interval, okay, your rule is you're trying to get x by itself in the middle. So whatever you do to the middle, you have to do to the two outside numbers. So in this case here, I've got a minus 3, so I have to add 3 on both sides of it. When I do that, I get a 1 less than 2x less than 7. Okay, and then again, I'm trying to get the x by itself, so I have to divide everything by 2. And when I do that, that ends up giving me a 1/2 less than x less than 7/2. Okay? So that's the same with our bounded. Unbounded intervals are our OR statements. These are much easier. When you guys have an OR statement, unbounded interval, solve this one, get your answer, then solve this one and get your answer. Okay, the other thing I want to talk to you guys about is when you're solving these unbounded or bounded intervals, remember on your guys' exam, they are going to ask that you write those in interval notation. So this right here would not be our final answer. Okay, remember this is bounded, and bounded intervals means that it's trapped between those two numbers. I'd have open circles because it's just a less than sign and it's trapped in between. So my final answer in interval notation would be 1/2 to 7/2, and since they're both less than, you're going to have parentheses. Okay. If I have unbounded, remember that's where I'm going from negative infinity to a number, and then that number to positive infinity. Okay. So practice writing your answers in that interval notation just so that you guys are ready for your guys' test.